All right, here is the worksheet from today in class. What we use the definition of the derivative and the difference quotient over and over. So I wrote the definition of the derivative here and the difference quotient. And let's get started. All right, so find f prime of 2 using the definition of the derivative. So using this thing right here, find f, right, bad start, f prime of 2. So this formula gives us f prime of a, so our a is equal to 2 here. So what we want is the limit as x approaches 2 of f of x minus f of 2 divided by x minus 2. But f of x is equal to 8 over x, so we have this limit is the same as the limit of f of 2 is 8 over 2, which is 4, over x minus 2. And we can simplify this, get a common denominator, and you get 8 minus 4x over x divided by x minus 2, maybe over 1, which if you factor out a negative 4, if you get a little bit clever, you're left with x minus 2. And now we're just doing algebra. These cancel out. And what we're left with is this is equal to the limit as x approaches 2 of negative 4 divided by x, which is a limit we can evaluate. You can just make x equal to, and you get negative 2 as your answer. So I guess really I should write limit in each of these steps, but I'm going to be lazy. I'm going to write it in the first step and the last step in all of these problems just to save a little bit of time. Okay, so now it says do that same thing, get that same answer, but use the difference quotient. Use this guy over here. So, all right, f prime of 2 is equal to the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h. So f of 2 plus h, here's f of x, so f of 2 plus h is 8 over 2 plus h. F of 2, we already figured that out, it's 4 divided by h. Now we want to do some algebra here. See, we need a common denominator of 2 plus h. So the way you get that is you multiply this by 2 plus h over 2 plus h, and you get 8 minus 4 times 2 plus h divided by 2 plus h all over h over 1. Change it from h to h over 1 because in this next step I'm going to flip the denominator upside down. See, up top here I have 8 minus 4h, so I just have negative 4h over 2 plus h times 1 over h, which is good because my goal in all this was to cancel out this h, and I can now do it, which means I am on the right track. So this is equal to the limit as h approaches 0 of negative 4 over 2 plus h. See, when h, we can evaluate this limit. This is negative 4 over 2. In other words, negative 2 matches up. Good sign. Whew, that took a while, and that's only the first problem, but we'll power through. Second one, g of x. Find the equation of the tangent line to this using the definition of the derivative. Okay, definition of the derivative says that g prime of 9, something that I'll need to know if I want to find the equation of the tangent line to g of x at x equals 9, is equal to the limit as x approaches 9 of g of x minus, I'll write that out, g of x minus g of 9 over x minus 9, which is equal to g of x is the square root of x, so it's square root of x minus the square root of 9 divided by x minus 9. So what we need to do is cancel out this and this x minus 9, but we have a nice little trick that takes care of that. You can multiply the top and the bottom by the conjugate of the top. In other words, you can rationalize the numerator. And I know it seems like this doesn't do you any good because sure, you get rid of the x in the numerator, but the bottom still has a square root. You get rid of the square root in the numerator, but the bottom still has one. But it turns out that that's okay, because what we've managed to do is get an x minus 9 in the top and an x minus 9 in the bottom, which cancel out. So this is equal to the limit as x approaches 9 of 1 over square root of x plus 3, which is a limit we can evaluate. Sticking a 9 here. Square root of 9 is 3. You get 1/6. So what we just figured out is that the slope, maybe m equals this. We need, if we want the equation of the tangent line, we need a point. So let's see, maybe I'll switch colors here. We know that x equals 9. So we get the point 9 comma f of 9, which is 9, and then stick a 9 into this function and get 3 out of it. So here's x1, here's y1, and here's m. So now I can find the equation of the tangent line. Two ways to do it. I'll do point slope form. Y minus y1 equals m times x minus x1. That is y equals, that's not a y. Y equals 1/6 x. Let's see, if you distribute the 1/6 through, you get 9/6, which is 1.5, and then you add 3 to negative 1.5, and you get positive 1.5. That is positive 3/2. And this right here is our equation of the tangent line. Okay, conform. I think that should probably be confirm your answer using the difference quotient. Okay, so all we can do using the difference quotient is we can figure out g prime of 9 now by saying it's the limit as h approaches 0 of f of x plus h. I guess these are really g of x plus h is what we're calling this function. Sorry, g of 9 plus h minus g of 9 divided by h. So it is the limit. Actually, I'm not writing the limit each time. I'll leave that out. G of 9 plus h is the square root of 9 plus h minus the square root of 9 is 3 divided by h. I want to cancel out this h. The only trick we have for doing these is multiplying by the conjugate. So let's see, I should switch colors. Maybe we'll go to orange and multiply this times the square root of 9 plus h plus 3 over the square root of 9 plus h plus 3. And what you get is 9 plus h minus 9 divided by h times square root of 9 plus h plus 3. But up top, some stuff will cancel. I lost my canceling color, but I guess I can do it in any color I want. Plus 9 minus 9, h. What I'm left with is this is equal to the limit as h approaches 0 of 1 over the square root of 9 plus h plus 3. That's an h there. But if we make h go to 0, this is just the square root of 9, which is 3. We end up with 1/6, same slope we got up here. Check, we must have done everything right. All right, number 3. Good God, how long has this been going? 8 minutes already. All right, maybe I'll do this one and then I'll make this second half a new video. So find the height of a ball. Oh, this function gives the height of the ball. Find the speed of the ball at time 2 using the definition of the derivative. What they're saying is find h prime of 2. Using the definition of the derivative, that's the limit as x approaches 2 of, I guess, t approaches 2 of f of t minus f of 2 over t minus 2. Might be helpful to just change all these t's to x's if you're more comfortable with x's, but I'll do t's because that's what the function is here. All right, I can do that. F of t is negative t squared plus 6t plus 7. From that, I want to subtract f of 2. F of 2 is negative 4 plus 12 plus 7. If you stick in a 2 everywhere up here, negative 4 plus 12 plus 7. That is all divided by t minus 2. So what I have is negative t squared plus 6t and then plus 7, and what's this net out to be? 19, 15. So 7 minus 15, get negative 8 over t minus 2. And so what we got to do is factor out a t minus 2 from the bottom, or from the top. Let's see, one way to do that is factor out a negative from everything, and then t minus 2 times what would give me t squared minus 6t plus 8. I guess that would be t minus 4 over t minus 2. And what's good about this is now those cancel out, and what we're left with is this thing is equal to the limit as t approaches 2 of negative t minus 4. So that's negative 2, in other words 2. Okay, find that again. This time use the difference quotient. All right, so h prime of, be a little, well, we'll see. H prime 2 is equal to the limit as h approaches 0. Don't confuse this h and this h. This h is how far apart the 2 points are when we're coming up with the slope of the secant line. This is the name of our function. Of h of, yeah, this is all sorts of confusing. 2 plus h minus h. Maybe I should just use f's. H of 2 divided by h. Okay, h of t is this, so h of 2 plus h is negative 2 plus h squared plus 6 times 2 plus h plus 7. So that's just this thing right here. And from that, I want to subtract h of 2, which I figured out up here. See, I used f's up here. I should have used h's. I figured out that was, what did I say that was, 15? Yeah, 15. That whole thing divided by h. Okay, so 2 plus h squared is 4 plus 4h plus h squared. Be careful, you have to FOIL that out. And so if you distribute the negative sign through, you get negative 4 minus 4h minus h squared. And then if you distribute the 6 through, you get 12 plus 6h, and then plus 7 minus 15 over h. And I know it looks really bad, but things should cancel out pretty nicely here. We have a negative h squared, minus 4h plus 6h, so that sounds like plus 2h. And then negative 4 plus 12 gives me positive 8, plus 7 gives me 15, minus 15 gives me 0. So I get to here. This simplifies to this, which is good, because now I can cancel out, I can factor out an h from the top and cancel it with the h in the bottom. And what I'm left with is this is equal to the limit as h approaches 0 of negative h plus 2, which is just equal to the number 2. Same thing we got here, which is good. And so maybe I'll cut off this video here and do the second half of this in a new video. So that is the end of these solutions.